In this tutorial, we will learn how to calculate determinant of a 2 by 2 matrix, determine the minors, and find determinants of a 3 by 3 matrix. So let's get started with determinants. Determinants are the scalar quantities, and they are calculated for a square matrix, that is, a matrix that has equal number of rows and columns. For any matrix A, its determinant is written as shown here. And please do not get confused with those two vertical bars. It does not mean the modulus. Determinant can be positive or negative. As we already mentioned, these are the scalar quantities. Okay, so let's see how we can write determinants for a 2 by 2 matrix. So for 2 by 2 matrix A, determinant can be written as shown on right. The elements are kept in between two vertical bars. Similarly, for 3 by 3 matrix B, its determinant is shown on right. And similarly for matrix C, its determinant is shown. Okay, now how to calculate a determinant for a 2 by 2 matrix? So here we have a 2 by 2 matrix A with elements A, B, C, and D. And to calculate the determinant of 2 by 2 matrix A, we can cross multiply the elements starting from top left and then subtract the products as shown. Alright, so let's do some examples. So we have here a 2 by 2 matrix B with elements 1, 2, negative 3, and 4. To find the determinant for matrix B, we can cross multiply the elements starting from top left and then subtract the products. That is, we can multiply element 1 with 4 and element negative 3 with 2, and then we can subtract the products. As a result, we get 10, and that's the determinant of matrix B. Okay, similarly, we can find determinant for matrix C, which is shown here. Okay, so now let's talk about minors. Minors of an element of the matrix is equal to the determinant of remaining elements of the matrix obtained after deleting the row and column containing that element in the matrix. Well, that's too much, right? So let's take a look at some examples and be clear about it. So here we have a 2 by 2 matrix A with elements 1, 2, 3, and 4. So for each of the elements in matrix A, we can find its minor. So the question is, what is the minor of element A? So to find the minor of element A, we delete the row containing element 1, which is the first row. Similarly, we delete the column containing element 1, which is column 1, right? And we are left with element 4. Well, we need to determine the determinant of element 4, but it's just a single element, right? So determinant of a single element is itself. So minor of element 1 is 4. Similarly, minor of element 2. Well, we can delete the row containing element 2, which is the first row, and we can delete the column containing element 2, which is the second column, and we are left with 3. So minor of element 2 is 3. Similarly, we can calculate the minor of element 3. Turns out it's 2, and minor of element 4 turns out it's 1. So it was pretty straightforward for a 2 by 2 matrix, right? What about a 3 by 3 matrix? Oh, now seems a bit complicated, right? But we can go through it. So what's the minor of element 1? So to find the minor of element 1, we delete the row containing element 1, which is the first row, and we also delete the column containing element 1, which is the first column. In doing so, we are left with a 2 by 2 matrix, of which we want to calculate the determinant. That would be the minor of element 1, right? Okay, but we already know how to calculate the determinant for a 2 by 2 matrix, right? So using the rule, as we've seen in previous slides, we can calculate the determinant. And turns out the minor of element 1 is -3. You can do the math, right? Similarly, to find minor of element 2, we delete the row and column containing element 2, which are basically first row and second column. And we are left with a 2 by 2 matrix, which is 4, 6, 7, 9 are the elements. And we can calculate the determinant of that 2 by 2 matrix. Turns out the determinant is -6. So minor of element 2 is -6. Similarly, we can calculate minor of element 3. Once again, the same rule. We can delete the row and column containing element 3, and we are left with a 2 by 2 matrix, of which we can calculate the determinant. That would be the minor of element 3. Following the same trend, we can basically find the minor of remaining elements. So for example, here I have shown the minor of element 4, element 5, element 6, and you can do that for elements 7, 8, and 9. Okay, now let's try to find the determinant of 3 by 3 matrix. For any matrix, we have elements in them, right? And for elements in a matrix, we can assign signs for each elements relative to their position, which are basically called the anchor signs. So for matrix B, for 3 by 3 matrix B, I have anchor signs as shown on top right. So for element 1, the anchor sign is plus. Element 2, it's minus. Element 3, it's plus, and so on and so forth. So now we know the anchor signs for the elements of the matrix. We now know how to find the minors for the elements in a matrix. And we also know how to calculate the determinant, right, for a 2 by 2 matrix. That means we are well equipped with the tools needed to calculate the determinant of a 3 by 3 matrix. I'll walk you through the steps how to find the determinant of a 3 by 3 matrix. So, step 1, for a 3 by 3 matrix, we can pick a row or column as an anchor row or anchor column, and we stick to that row or column. But you can pick whichever row or whichever column you want, but whichever you pick, you need to stick to it. And for step 2, we find the minor for each elements for the anchor row or anchor column we chose in step 1. And finally, we multiply each element from the anchored row or anchored column with its corresponding anchor sign and its minor that we found in step 2. And we add them all together to find the determinant. Well, seems a bit complex, right? Well, no. We can just do an example, and I guess that would make our life a bit easy. Okay, So for matrix B, the determinant, we want to find the determinant. All right. So the first step is we want to pick a row or a column as an anchor row or column. So let's pick the first row. The first row has elements 1, 2, and 3. That's the first step. You can pick any row you want, but you need to stick to that particular row you pick while you are doing the math. All right. Now we have the first row as our anchored row, and step 2, we want to find the minor for each element for the anchored row, which is the first row for us. Okay, so to calculate the minor of element 1, well, we delete the row and column containing element 1 from the matrix, right? We are left with 2 by 2 matrix, and we can find the determinant. And that determinant would be the minor for element 1. Okay, easy, right? Similarly, we want to find minor for element 2 because that's the second element from the anchored row we chose. And we have minor for element 2 as shown. And finally, we want to find minor for element 3, which is the last element from the anchored row. We can again find the minor for element 3, which is shown here. All right, and the last step. Now we want to multiply each element from the anchored row with its anchored sign and its minor that we just found in step 2, right? And we add them all together. Okay, so let's do it. Okay, so the first element from the anchored row was 1, and its anchored sign is plus. That can be seen from the very top right, times the minor of element 1, which is determinant of a 2 by 2 matrix. And we add it to the next term, which is obtained by multiplying the second element from the anchored first row multiplied by its anchored sign, which is minus, multiplied by the minor of element 2. And we have the last term that is for element 3. So we multiply element 3 with its anchored sign, which is again plus. That can be seen from the top right. And multiplied by the minor of element 3. And we add them all together. Okay. So that's the step 3. We multiply each element from the anchored row with its anchored signs and with its minor. Now we want to compute the determinant, right? That's the only thing left for each of these minors. And we already know how to calculate the determinant for a 2 by 2 matrix, right? We cross multiply the elements starting from top left and then subtract the products. We can do that. That's easy math, right? So once we do the math, we end up getting 0. That's the determinant for 3 by 3 matrix B. And to let you know, or to summarize, or to just walk you through the steps once again, what we did was, for the matrix B, we first chose the anchor row. Well, you can select second row or third row or first column or second column or third column. It's up to you. But whichever row or whichever row column you pick, always stick to that row or column. So here in this example, I chose first row and we just stick to it. And in the second step, we want to find the minor for each elements from the anchored first row. And in the last step, we multiply each element with its anchor sign and its minor found in step 2. And we add them all together. And in doing so, we end up getting 0, which is the determinant for the matrix B. So this is how we can calculate the determinant for any 3 by 3 matrix. And to let you know, we chose first row as an anchor row, right? You can choose second row or third row or first column, second column or third column. It's up to you. You have freedom. And whichever row or column you choose, you stick to that row or column. And when you calculate the determinant by sticking to the column or row of your choice, you will end up getting the same number as for the determinant, right? So in short, determinant can be calculated using any rows or columns. You don't have to stick to the first row or the first column. But typically we stick to the first row because it's easy, well, to go through. Well, I don't know. It depends. All right. So to summarize, so what we did today, we talked about determinants. These are the scalar quantities, and they are calculated for a square matrix, which has equal number of rows and columns. And to find the determinant of 2 by 2 matrix is easy peasy. We can cross multiply the elements starting from top left and then subtract the products. And we also learned how to calculate the minors, right, for a 3 by 3 matrix. Well, we can do that for a 2 by 2 matrix and even for a 4 by 4 matrix. And to find the determinant for a 3 by 3 matrix, first step is to anchor a row or column and stick to it. And then second step, we can calculate the minors for the elements in that anchored row or column. And lastly, we can multiply each element from the anchored row or column with its anchored sign and the minor we found. And we can add them together to get the determinant, right? So this is the basic flow that we can adopt to find the determinant. All right. Thank you all.